Welcome to the Green Mech TV channel. In the quiet landscapes of Finland, a new chapter in green energy takes shape. This is the construction of a Lagerway wind turbine, a remarkable blend of engineering and environmental vision. The journey begins at specialized factories, where massive blades are molded from advanced composites, light yet incredibly strong. Each nacelle is built with direct drive technology, reducing mechanical wear and boosting efficiency. Tower sections, designed in modular form, are carefully engineered to simplify transport and assembly, ensuring every part arrives safely at the site. Once delivered, the challenge of scale becomes clear. Tower segments stretch skyward, as heavy-duty cranes lift and position them with precision. The nacelle, the heart of the turbine, is hoisted into place before the giant blades are mounted one by one. Every connection must be flawless. The alignment of hub, blades, and tower is critical to both safety and performance. Beyond the steel and composites lies a greater purpose. Every Lagerway turbine contributes to energy independence, reduced reliance on fossil fuels, and meaningful action against climate change. From transport convoys to final assembly, the process shows how precision engineering and sustainability work hand in hand. When complete, the turbine stands tall above the finished landscape, harnessing winds that sweep across open fields and forests. Each rotation generates clean, renewable power for thousands of homes, electricity without smoke, without fuel, and without carbon emissions. And as the blades begin to turn, the promise becomes reality, a future where technology, environment, and community thrive together under the power of the wind. Modern wind turbine blades are engineering marvels, massive, lightweight, and built to harvest energy with elegance. Imagine a blade stretching longer than 2 Olympic swimming pools, crafted from advanced composites to withstand wind, fatigue, and storms. At the production facility, teams mold and trim these 100-meter-plus blades with laser precision. Every contour is optimized aerodynamically to catch the slightest breeze and turn it into clean electricity. The sheer scale is staggering, but it's purpose-built, built to reduce reliance on fossil fuels and shape a greener planet. Transporting these giants? It's an extraordinary feat. Special carriers, guided by reconnaissance teams, navigate tight curves and highway overpasses to deliver each blade safely to wind farms. Then, with the help of towering cranes, blades are mounted onto hubs, completing the turbine assembly in the open air. Once raised, the blades begin their silent work, rotating gracefully and generating megawatts of renewable power. Each spin cuts carbon emissions, powers communities responsibly, and signals our collective commitment to sustainable energy. These record-setting blades are more than steel and composites. They're symbols of innovation, sustainability, and our power to change the world, one clean revolution at a time. Welcome to ORE Catapult's blade test facilities, where wind turbine blades are pushed to their limits before they ever spin in the sky. Imagine blades longer than a football field. These massive structures must endure extreme loads, fatigue, and environmental wear. Here at the lab, engineers simulate decades of service in just hours. Powerful hydraulic systems bend the blades thousands of times in multiple directions, wringing out design weaknesses. They also expose them to rain, UV, and erosion, to ensure coatings and materials hold up long-term. This rigorous testing gives manufacturers confidence that each blade will withstand storms, fatigue, and time, but safely, reliably, and sustainably. It's precision engineering, safeguarding the future of clean energy, one test at a time. Imagine a single blade longer than a football field. That's the innovation behind LM Wind Power's 107-meter blade, the first ever to exceed 100 meters. Engineered in France, this colossal component is built for GE's Haliade by 12 megawatts offshore turbine, today's most powerful wind turbine. In a massive factory, teams sculpt and refine this record-setting blade with precision. Lightweight yet extraordinarily strong, it's designed to endure decades of offshore winds and ocean spray. Its sheer size boosts energy capture, turning more wind into clean electricity and powering thousands of homes without burning fuel. When this blade spins, it symbolizes more than raw power. It tells a story of human ingenuity pushing boundaries for a sustainable future. With every rotation, we harness nature's breath, transforming it into renewable energy that respects our planet and lights our world. Beneath the open horizon, far from shore, an engineering giant rises, a $10 million offshore wind turbine built to capture the relentless energy of the sea. It is more than a structure of steel and blades. It is a promise of clean energy and a step toward a sustainable future. The process begins in specialized factories, where immense blades are molded from advanced composite materials. Each blade stretches more than 100 meters, light enough to catch the faintest breeze, yet strong enough to endure decades of salt spray, storms, and ocean winds. Tower sections are forged from high-strength steel, built to withstand not only their own weight, but also the pounding waves and constant forces of the sea. Transporting these massive components is a logistical masterpiece. Blades are carried on custom barges, escorted through narrow shipping lanes. Tower segments are stacked and secured, then towed to offshore staging areas. Every move is coordinated with precision, from tugboats and cargo vessels to marine pilots guiding them safely into place. At the installation site, specialized jackup vessels drive their legs deep into the seabed, stabilizing themselves against the shifting ocean. On deck, some of the world's largest cranes come to life. Tower bases are lifted and bolted to steel foundations anchored securely beneath the waves. Nacelles, the central hubs housing generators and drive systems, are hoisted high and connected. Finally, the enormous blades are mounted one by one, aligned with millimeter accuracy, so the turbine can perform at peak efficiency. This floating city of workers, cranes, and machines operates like clockwork, battling tides, winds, and weather windows to complete the turbine in record time. Once assembled, the tower stretches hundreds of feet into the air, visible for miles, a new landmark of clean technology. This $10 million turbine is not just a feat of engineering, it is a beacon of progress. It stands tall in the middle of the sea as a symbol of global ambition, harnessing the power of nature, protecting our planet, and leading the way into a cleaner, greener future. And when the blades begin to spin, the transformation is immediate. Each rotation converts invisible wind into megawatts of power, enough to supply thousands of homes with electricity that is clean, renewable, and carbon-free. Offshore turbines capture stronger, steadier winds than those on land, meaning higher efficiency and more consistent energy production. Beyond the machinery, the impact resonates far deeper. Every kilowatt generated offshore reduces reliance on fossil fuels, cuts greenhouse gas emissions, and eases the strain on our atmosphere. Offshore wind farms become more than energy projects. They are environmental guardians, proving that innovation and responsibility can coexist. Beneath wide-open skies, a new energy landscape is born. This is the complete installation of a wind farm, built from bare ground into a field of towering turbines that will transform invisible wind into clean, renewable power. The process begins with foundation work. Teams excavate massive pits and pour reinforced concrete bases, designed to anchor each turbine against decades of storms. Steel bolts are set deep, ready to connect the rising tower to solid ground. Without this step, no blade could ever safely spin. Next comes transport. Tower segments, nacelles, and blades stretch across highways on convoys of specialized trailers. Each move is carefully planned. Police escorts, survey crews, and drivers trained to navigate sharp turns and narrow bridges. Every journey is a feat of logistics, delivering components that measure over 80 meters long and weigh up to 50 tons. On site, cranes dominate the horizon. Tower sections are lifted one after another, locked precisely into place. Each bolt, each weld, is checked and rechecked, because when the structure stands hundreds of feet tall, there's no room for error. The nacelle, housing the generator and drive systems, is hoisted high and positioned on the tower's peak. Finally, blades arrive. Suspended delicately by crane lines, they are fixed onto the hub one by one, forming the iconic rotor. The work is as much about patience as it is about power. Crews often wait for perfect weather windows, winds calm enough for safe lifts, skies clear enough for precise alignments. A single gust can delay operations, but safety and accuracy always take priority. But this story goes beyond construction. Every turbine erected is a promise of cleaner air and reduced carbon output. Wind farms help nations diversify energy supply, reduce dependence on fossil fuels, and build resilience against climate change. Communities nearby benefit not only from renewable energy, but also from jobs, infrastructure, and pride in a sustainable future. From foundation to rotation, the journey is monumental. Concrete, steel, and composites come together through human effort and ingenuity, standing as symbols of progress on the horizon. What once was empty ground is now a field of giants, silently harvesting the wind to power tomorrow. When the final blade is secured, the turbine transforms from steel skeleton to living machine. Slowly, the rotor begins to turn, each revolution catching the wind, each spin channeling energy into the grid. Multiply this by dozens of turbines, and an entire farm comes alive, capable of powering tens of thousands of homes with no fuel burned, no emissions released.